going back to my notes, there's a few different articles that you can look at in terms of reading up on how this figures in terms of what documentation that Android itself has provided. A lot of it is under this device compatibility header. So these are kind of a series of tutorials related to device compatibility. So I want to take a quick look through some of the things they say and point some of those things out before we get into trying to make this happen and trying to code this out. So just a general overview here in terms of what is device compatibility, why you might want to do it. I mean, our main goal, as I'm sure you can figure, is we want to be able to reach as many users as possible, right? So the more we can make our apps compatible to different devices, the bigger user base we can have, right? So we want to hit as much of that as we can. There's two general ways to do that. One way to do that, and one approach you can say, is, hey, we're going to ship an app, and we're going to say that app supports all devices out there. We'll just provide different resources for different devices, which does mean you're shipping out an app potentially that has all of the resource files for every single screen size and every language and every different device that it could go to, right? Which also in the end can make your bundles a little bit bigger. It means that your app is a little bit bigger. There's a system now that's newer called the app bundle system. You can, instead of building an APK, you can build an Android app bundle. And that way Android kind of deals with building or separating out all of the different variations of it into smaller APKs that you can ship out. So Android does kind of already have a system that they're working on that reduces the overall size of it, but that's one general way you can go about it, which is the way we're going to take it. The other way you can go about it is actually when you upload things to the Play Store, you get to decide what devices your app works on and what devices it doesn't. So for instance, when I upload an app to the Play Store, I can decide that this app only runs on tablets and not on phones, or only on phones and not on tablets. You have that option. Or you can say, hey, this app is only available to devices that have a camera or a GPS, right? Or a SIM card. You can limit it based on a variety of things, right? And so there's two ways there, right? You can say, okay, here are the limits. So if you don't have this, you can't install it at all, which is what some apps do, right? Or you can say, hey, I'm going to push out two versions to the Play Store. This version is my phone app, and here is my tablet app. And some apps do that as well, where you'll have two slightly different versions of the app, one for phone and one for tablets. You can do both approaches. Companies do both approaches all the time. I would say it's generally preferable to have one app that works everywhere, but there are some apps that do that differently, and it's notable that happens sometimes with games, where there's enough difference and competitive difference where it actually might not be fair to put people that are playing on a phone into the same categories people are playing on a tablet. It might not be very fun in multiplayer if you have multiplayer, depending on what it is, right? So there are reasons why you might want to segregate that, but that's not the only way to do it. So that's one thing to be aware of. It's the Play Store is also involved in this decisions. We really aren't going to do much with the Play Store, but you kind of understand where that factors in. So some things that you can control in terms of whether or not your app is available. You can do it based on features like camera, GPS, Bluetooth, etc. You can do it based on the particular platform version they have. So you can say, hey, you can only install this app if you have Android X or late or higher. So when we started these apps, we said API 24 or higher, right? So that means that anything that's 23, 22, etc., it won't work on, which is why it doesn't work on my 10-inch tablet, my Samsung Tab. I think it's a Tab 3 or Tab 4, because it's too old, right? It doesn't have the right version of Android. So you can set those things. There is a there is a burden to the more versions you support, and there are a lot of features that aren't available on others. So there's plenty of reasons why you might not want that to go back to the beginning of time and back to Android version 1.0. In fact, most apps don't go to version 1.0. They maybe go to Android 4.0 at the earliest nowadays. Okay. And then screen configuration is another side there where you might say, hey, you have to have a screen that's this size or bigger to install. So you can do those kind of things. In terms of how you set up some of these things, in terms of features, part of that involves updating the manifest. So in the manifest, you can say, hey, here's the features that I want to use. We added this for the camera. We can say, hey, we want to use the camera, but we made it required false because it was optional. But you can say that some of those things are required. Okay. So those are things you can do. Platform version, that's where we set this in our Gradle files. That's set to target 20. I think actually it's a minimum SDK of 24, and our max, I think now, is 31 or 32, depending on what point in the semester you started the project. Okay. And we can also, in there, sometimes we need to call different functions based on what particular app we're running. So you can go off of build.version.sdk int. That will tell you what particular version of Android they're actually running. So sometimes you do, we haven't done this semester because we're kind of trying to avoid that, also partly because we're targeting 24 or higher. So we've skipped a lot of the compatibility issues. It used to be a problem where you needed if statements, but sometimes it does come down where you need to say, hey, the API has changed, do it this way on older devices and this way on newer devices. Yeah, so you can do that at runtime if you do need to have different behavior. Screen configuration, they talk about there's some sort of categories you can deal with. This is somewhat of an older way of doing it. It's kind of come and gone, where we used to kind of bucket things as small sizes, normal, large, extra large. The problem with that is, again, you largely care about the width of the device and less so the height. And those categories were kind of didn't age well. Plus, they're also based on the combination of width and height. So you also then had to deal with orientation. So you often had, here's my small and portrait, et cetera, et cetera, et cetera. Okay. So those are some kind of overview in terms of device compatibility. What we're chiefly concerned about, though, is screen compatibility. That's really what I want to talk about today. Is really I'm focused on the screen compatibility side of things. Okay. There's kind of two pieces to that. One piece of that in terms of screen compatibility is the size. Another part of that is the density. Okay. So we care about both adapting our apps to different screen sizes or screen orientations, as well as adapting them to different densities. Okay. And so those are both problems we need to address. Is everybody on board? Okay. So in terms of screen sizes, there's a few ways to go about that. One of the important things to do is make sure you're using flexible layouts, and that's basically down to using constraint layout. If you're starting with constraint layout, it's already got some flex in it to where, okay, things can move around and the constraints will just kind of figure it out for you. So it's not strictly defined that it has to be pixel perfect. It's here. It's like, okay, this can be as wide as it needs to be, especially because I have to deal with translations, right? I need to have it kind of grow and adjust. So one thing you obviously don't want to do with Android, and I would recommend this to you for sure, never make a Photoshop mockup, ever, of an Android app. It's a recipe for things not working out for you. Because as soon as you say, hey, I want it to work this way, and you mock it up in Photoshop, you're going to find almost no device that has exactly that size that you mocked up in Photoshop. because it turns out, on average, whatever you take as an average size, as it applies to people and other things, if you take an average, nobody ever has that average. So, you want to start with, things more generic. This is why I usually mock things up in balsamic, so it's more loose and it's not, hey, I expect it to be exactly pixel perfect this size, because it rarely will ever work out that way. Make sense? So, flexible layouts is pretty important. Sometimes we also need to provide alternates, which we talked about earlier in the semester. I want to kind of return to. But sometimes we have, hey, here's the phone version of it, and here's the tablet version of it, because, or the portrait and the landscape version of it, because at some point, you do actually need different layouts, right? It can flex to a certain amount, but it can only flex so far. So in terms of flex, I could say, hey, well, we'll reuse the same layout for all of these different phones. They have just slightly different sizes, or at least all of the different phones in portrait. But when we talk about tablets, well, a tablet is big enough from a phone, especially in landscape, that we kind of do need a different layout for tablet landscape for sure. Does that make sense? And we can make better use of that space. So oftentimes these two are different, and that's what they have here, right? You have a phone in portrait and a tablet in landscape, and they've got significant differences. Also important in there is working with images that are stretchable, okay? There's a few different ways to do that, but we oftentimes, if we start with an image, say you've made it in Photoshop, it's got a certain size. In general, most of those images are not going to scale really well to other sizes. You're not, if I try to stretch the image in its width in a different amount than I stretch it in its height, it's going to look stretched. You're going to be able to tell those kind of things. So even just basic things like a background for a button, where it's just supposed to look like a box and got some curved corners and maybe some shadows and roundedness. If you stretch that by a different amount horizontally than you do vertically, you're going to be able to tell that. Okay, so we need ways to work with that. One of the tools that we have that we can do that with is you can just say, hey, we'll make the backgrounds, we'll make them vectors, right? We'll make them as SVGs, and then we can kind of let them stretch and let them change, and SVGs will just know how to draw themselves correctly at those different sizes. Okay, so raster images is where you get most of the problems, so let's avoid using rasters. Okay. That being said, we do sometimes comes into issues where we can't necessarily use a vector image because either it's not available or because your designer just isn't used to or hasn't created those artifacts as SVGs, as a vector image. So one of the things that we do have in Android that you see a little bit less of, but I actually used to use quite a bit because it was before Android fully supported vectors, which is kind of like a newer thing. We're talking about devices here, tablet here that's 5.0. We would do these 9-patch images, which they kind of allude to here. And the idea with a 9-patch is you subdivide the image, and this is usually used for buttons. You say, hey, here's the background that I want to use for my button. I subdivide it this way into basically 9 images. Basically, I subdivide it into 9 images. So we have a center part of what that button is. That's where the text is going to appear. That part is usually a solid color. So as long as it's a solid color, I can safely stretch it up, left and right, up and down, change the height and the width at a different ratio, and it's okay. It's not true for every image. This especially breaks down if you put a gradient in there. But or if you have an image or anything more fancy, but as long as it's a solid color, I can stretch this part at a different ratio. Okay? The corners or sorry, let's talk about the edges. So these two edges, the top and bottom edges, I can stretch them horizontally safely usually, as long as they're just like a line, right? And say, okay, well, we can stretch that horizontally, but I can't stretch it vertically. So this gets stretched in both directions. This only gets stretched horizontally. These two only get stretched vertically. And then the corners don't get stretched at all. Corners stay their size. So that's what you see when you're doing with a 9-patch. Okay? I don't want to get into 9 patches. We don't have any button backgrounds right now in our app right now, so that may be something we talk more about when we get to theming, but that's one way that you can work this around and with the images, okay? If you're dealing specifically with backgrounds, that's one approach that we take. Backgrounds or borders, you might use a 9-patch to kind of put that on. The good news is Android has a way to do that without actually breaking into the nine different images. You just kind of turn it into a 9-patch, and you can just mark which parts are which. So it makes it a little bit easier to work with than having to completely break it apart into 9 pieces. Density also matters. So for instance, if you're looking at different screen sizes, you can see the text on the right is a lot more clear than the text on the left. And in fact, if you're looking at this on your screen, I think there might be a grid on there, which is hard to see on the projector. But the point is that the grid of pixels is more dense on that right screen and less dense on the left screen, right? So the pixels are quote unquote bigger because the density is lower, right? So density and the size of the pixels are kind of inversely proportional. One goes up, the other goes down. So, you have a screen that's more dense, then text is going to look bigger. It's going to look kind of more defined. But you also need kind of different images. So oftentimes, for say, hey, I have a screen on the left which has a relatively low density, okay? There I'm going to need images with less pixel data, so I actually can use smaller files, versus the screen on the right, I need bigger files with more pixels in them. Does that make sense, everybody? You can get this both ways. So part of it is kind of, there's a trade-off between size. There's another side that is there's a trade-off between resolution and such. Okay. Another question. So I take this 10-inch tablet, okay, and my phone. Which of these two has the bigger density? Which of these two devices would you figure is more dense? Phone. Which one has more pixels? This is a bigger device, right? This is a smaller device. This device has more pixels. This device has more pixels than this bigger device. It's kind of backwards, right? So when we're talking about densities, the thing you need to understand is density isn't necessarily directly correlated to the size of the device, right? I can have a nice big device with a really low density. In fact, if you're looking at most TVs have big pixels, okay? So the pixels are often bigger on bigger devices, rather than being smaller or being more of them on a bigger device. One of the things to understand in terms of battery usage is kind of correlated to the amount of pixels you have, more than the screen real estate. So, or at least to some extent, it's correlated to both. So, one of the things to be, where was I going with this? Density. So one of the things that this kind of means in terms of density is that oftentimes we need to provide different versions of our images. So for devices with a higher density, we need to typically provide a higher resolution icon. So anytime you have a PNG file, you're going to have a higher resolution version and lower resolution versions that you're going to use appropriate to whatever's there. So for instance, the way that these categorize on Android, the baseline is 160. I don't remember what it's going to be. But let me grab this marker. The baseline is 160 dp. That's considered, historically, been the baseline resolution for Android devices. Okay. There are very few devices on the market that have that 160 dots per inch. Okay. There's very few that have that resolution now because it's a very low resolution. So 160 dp is considered, or DPI, dots per inch, pixels per inch, is considered medium DPI. The next step up for that would be double. 300 through 20 DPI is what we call high DPI. Okay? And no, just I had big heads up. So the way that these kind of correlate is they're largely doubled, if I remember right. So I think, and then 640 dots per inch, and I might be wrong with this, but that is 8x DPI. If I remember right, they're separated by steps or factors of 2. Let me pull up the table from here. Where's that table? Yeah, there it is. So it's almost, yes, it's not quite double, it's 1.5. So high is 240, and above that is 320 DPI. Okay. So those are kind of your baseline steps. There's also a low DPI, which is less than medium. There's, as far as I know, there are no devices on the market with low DPI. They're all pretty much medium DPI or higher at this point. Ironically, if you were looking for a low DPI device, what do you think it would be? How big do you think that device would be? Be huge, right? So actually, if you're looking for a device that is low DPI, it's all the way over here. You're talking about a TV. There are TVs on the market that are low DPI, less than, in that range of less than 160 DPI, dots per inch. Okay, but you're not going to find that on most Android devices. Usually they're pretty big. So medium is where they set the standard, which means that 160 dp is an inch roughly, is kind of that standard. But as things have grown up, right, our screens have actually gotten much higher resolution. So if you're looking at the table here, you can see that there is an extra high DPI, extra high DPI, extra high DPI. We've gotten up to 3x's so far. I wish that they picked a different naming scheme for it, because it makes it seem like extra high, double X, triple X are really rare, but they're actually pretty common. A lot of the flagship phones that you look, like what is the highest end smartphone that's out there? For most brands, it's going to be one of those top two densities of double X or triple X.
Well, I was just thinking, is it a possibility that they change the baseline density to like a higher one and maybe get rid of some of the lower ones?
It'd be nice if they did that, but because these things are hard-coded into all of the Android apps, unfortunately they can't change them without breaking all the apps on the market, which is why they've continued to add X's. I wouldn't be surprised if Google someday changes the names of these, and yeah, but the problem is if they change it right now, it would break everything. So they probably would have to go to something completely, totally different, and not just say, hey, medium is down here. Because medium's more, like extra high is actually more average than medium. So in terms of targeting your resources, you actually, I would target as one the medium, and then kind of things larger. I wouldn't worry too much about low because there aren't that many, but you also, the highest end is not as rare as you might think, is the big thing to point out. Does that make sense? You might look at that and go, oh, well, I don't need to worry about these two because there's not that many devices on the market, but there's actually a lot more devices with those extras than devices with lower resolutions. Okay. And the other side of things is too, if we're dealing with phones, we're down here. If we're dealing with tablets, we're up here. Right? Tablets are generally lower density, and phones are generally higher density. Part of that, and that just basically means the pixels are smaller. Well, why do you need that? Well, if you're talking about a smaller device, a smaller phone, you're actually usually using the device at a closer distance. You're usually got your face closer to the device, so inherently the pixels kind of need to be smaller because the device is slower. Whereas when people are using tablets, they hold it a little bit farther away. So that's kind of part of the trade-off. Okay. There's actually a lot of apps out there on the marketplace, even some popular ones that don't always work great on tablets. Actually, Pinterest is one of those that doesn't always work great on tablets because they have a lower density. So sometimes you'll find the images are a little bit blurry or things like that because of those density differences that you have to kind of account for. Okay, so that's one of those axes that I just want to call to your attention that we got to pay attention to. Other things we can do, so in terms of working with this density, oftentimes that means anytime we have a bitmap image, we have to provide alternatives. If it's a raster image of any sort, basically that's going to be all your PNGs and all your JPEGs. We generally need to provide more than one version of those in different sizes. Make sense? Versus if I've got vector graphics, then you usually can provide one, right? So if we think about our apps right now, right, where do we have images in the app? Where do we have images in that game library app? Well, we have thumbnails for the games. We have maybe banner images of the top of the game details. We've also got screenshots, okay? Those three are usually going to be more raster size. They're not really going to be able to make those into vector images, right? Those are generally pictures. So screenshots and banner and the thumbnail, those are all you're talking about vector images. So generally speaking, you need to provide a few different variations of those. Yes?
So that makes me wonder, how would that affect like the user profiles? Because like they upload an image, would that require them to upload two different ones? Or how?
So the good news is it means you effectively, you're kind of asking the right question. It means that we need to end up usually having more than one profile image, but we don't usually have our users provide those. Okay, how do we do that? Well, it turns out all those different variations are just different sizes. They're just different sizes of the same image. So as long as you start with a high-res image, I can scale that down to a bunch of smaller images. So that's the way you deal with that. Say, hey, let's take a picture with your camera. Start with a camera that's good high resolution ideally, which a lot of phones do have pretty good cameras, and we could just scale it down from there. It's also worth mentioning we're already scaling it down, so it doesn't have to be that high res, because we take an image that's this big, and then when we actually show it on their profile, it's much smaller, right? So it doesn't have to be that high res. So we're scaling it down already. We just then make a few different versions is what you would typically do. So I'd save those different variations into storage. Like here's my 640 and my 320 and my 160, and my 80s, and I'd store those just different files, and then when I'm running on the device, it's just a matter of saying, okay, well, go get this file or that file or that file, but that also means typically in the database, you're going to have paths to all of those. Or if you put them in folders, at least, or predictable names in storage, then you might be able to predict what they're going to be, and then you only have to store one. But that's oftentimes what that means for the profile image. Does that make sense? You just have to scale it down when you're uploading it and upload several file variations rather than just one. I'm not going to ask you to do that, but that's how you would solve that. Okay. The other side of things, if we're talking about screenshots and those kind of things, well, where are those screenshots hosted right now? Well, you have URLs in your database, but where are you actually storing the screenshot files? Externally, right? In fact, you probably took them from somewhere you found online and just dumped in their URLs, right? So you don't really have control over that image or how it's hosted to come up with the different variations, right? So usually when we're building apps, we want to make sure that those images are hosted on our own servers, so we then have that ability to have different versions available to us, right? So those are things that you'd want to have available, but those are outside the scope of what we can do because we're not controlling them, okay? Talking about things a little bit further down, remember I've asked you to sometimes get some icons from Flat Icon, right? So you went to Flat Icon, you downloaded those images. When you download them, there's actually a drop down to say, hey, I want this version, this size, right? If you look at that, well, so okay, you can go there and get multiple variations, pull them down, add them to your app, right? So that's kind of how we deal with that in the icon sense, is we just, ideally we have a place where we can get those, or if we are making those in-house, then you'd have the designer kind of start with the larger variation, and then you'd have to, from Photoshop or Illustrator, produce several variations that are smaller. So you'd get a set of PNG files instead of just one. Make sense? Versus vector image, that's kind of how we deal with that. Another things to mention in terms of compatibility and screens, actually the Android ecosystem is much wider than just what I had talked about. We were just talking about phones and tablets, or small tablets and big tablets. There's Wear OS, which is wearables like smartwatches. So you can run Android apps on smartwatches. You can run Android apps on Android TVs. You can run Android apps that run on cars. That's Android Auto. And then there's also this Chrome OS. You can get Chrome tablets, and they can actually run Android apps, kind of thing. So those are other kind of very different form factors. Those are not things we're going to cover in this class, but they are other things that oftentimes you might want to design your Android app for, is those other very different sort of ecosystems. It just turns out that those usually require a bit more change and quite a bit different set of APIs than what we're used to doing. So for instance, Chrome OS is largely operated with a mouse and keyboard, contrary to touch, which we're used to on mobile. You've got Wear OS, which is teeny tiny and usually circular and not square screens and things like that, right? Auto has its own restrictions. Another thing that's on the market right now are these foldable phones, right? So you can fold them in and they've got one size screen. You expand them out and they got twice as much screen space. So now you also have to have your Android apps deal with that. A little note on there as well is you've also got these notches on some phones now that kind of a cutout for the camera. So there's a camera on the front face, but the screen actually extends above. So you have this little notch in there where you can't draw anything. Which for ours, we've avoided that because we haven't gone into full screen mode. But if you go into full screen mode, then you have to deal with that notch. And you have to work around it. So if you're showing videos or making games or anything like that, then you potentially have to code around that notch. Okay. As I mentioned before, some of these things in terms of screen compatibility is possible in the Play Store to just say, hey, I'm just not going to support that screen factor. Or you could say, hey, I'm just not going to support foldable phones on your app. You're missing out on part of the market if you do that. So we generally want to allow for that. This foldables gives us an interesting case where the screen kind of changes midway in a different way than what we're maybe used to. So that's kind of a new thing, and it means there's additional things you have to adapt for versus just saying, hey, it's always going to be X size in portrait, or it might change. So that's part of why this, for those, it makes more sense to bucket things based on the width of the screen, because it actually works a lot better with foldables than doing it the traditional way. Okay? So those are some things to be aware of. Screen density is an important thing in there. Let's see, was there anything I needed to talk from screen sizes? There's a newer system, by the way, that they've added and they're working on. This is something that I wasn't fully aware of until recently. But there is a newer set of buckets that Android is adding, which is not the old size buckets, but there's some windows, what they call window size classes for horizontal and portrait. So they're starting to get on, and Android's realized that, oh, we need to bucket based on these kind of things. So they've got their own sort of breakpoints that they're starting to implement and such. I don't want to go through that process today, but that is out there and coming. There's also buckets on height as well, because it does turn out sometimes for some apps you do need to actually have breakpoints in the height size. Again, that would come up more if you were dealing with horizontal scrolling, but there's just other scenarios where you may care about doing a slightly different layout if the height is different. So they have that there to work with. There's some example code in here to kind of try and do that. But more so than anything, again, constraint layout is the main tool that they recommend using for adapting to different screen sizes. One of the things they mentioned, and we kind of talked about this already, is it's important to avoid hard-coded sizes, hard-coded widths and heights. You may prefer to use match parent and wrap content or 0DP. Those are preferred because they flow a lot better, which you can see here with that text. There's also a newer thing, which I want to maybe play around with next time, is this sliding pane layout, which is good for if you're doing a master details sort of flow. So what we've done so far is we have set up our list on one activity, and then our details are on another activity. So we have to, sometimes you may want to put those into one activity, right? So like the list is on the left, and then the details pops over on the right, which is one of the things I actually do want you to do at the labs, and I'll talk about next time as far as that goes. But that's a whole nother topic. But there's a new thing in here which I want to play around with that hopefully will make this easier. It's called the sliding pane layout. I'm new to it, so we'll see if it works. The example code that they have here is tied in with the newer navigation architecture that we have, so we'll have to kind of figure it out, because that example code won't particularly work for us. But that might be something that might make things work. So sometimes we want to combine and separate screens. Alternate layouts, we talked about this. Buckets. So one of the ways that we can do this in terms of having alternate layouts, you kind of see these two, main activity and then main activity.xml. Notice that there's that dash, W600DP. Anytime you see that dash in the folder, that says there's a qualifier. It says these resources only apply under these conditions. Now, those conditions can be, like we did with translations, could be based on the language or the culture. So it could be, hey, here's the strings for English, here's the strings for Spanish, here's the strings for Spanish Mexico, or English UK. But in this case here, we're saying W600DP. Okay. And this is a little bit different than what we did at the beginning of the semester, because when I created that layout variant, we kind of created it from the layout designer. That one actually creates it as SW600DP, or smallest width. Okay. That is not one I want to go down to, because it ends up being the same layout for portrait and landscape, which means you're back to making 6 different variations of the same layout. So we're going to do it this way, is the width rather than the smallest width. Okay. You can also add in orientations. So this is the traditional way of doing these different layout variations. You would say, hey, here's the base, which is phone portrait, add land, that's landscape on phones, or landscape on whatever. I also can combine in there and say, hey, the smallest screen width is 600, smallest screen width in landscape, and now I've got 4 different layouts for 4 different categories, right? So you can see that I can combine multiple different qualifiers. So sometimes you'll even see this combined with languages. So I might say, hey, here's the resource variants for it's 600 pixels or wider, and it's Spanish. Because you also, I have run into this where sometimes, in addition to changing things based on language, you also need to change things based on what size of the device it is. I think specifically where we ran into that was font sizes, where the font size kind of is like, okay, it needs to be this font size for tablets and this font size for phones to make it fit. And another big piece of this is if we move things more to fragments and less to layouts, it also gives us more of the ability to kind of restructure things and rejigger things to be different on different devices. Okay? So the fragments are part of this picture as well. It is important to test on a bunch of different screen sizes. Those are all the ones that they suggest in terms of ratios. That's a lot when you do that many. But there are a lot of different options, a lot of different things that can happen. So let me jump down here to just one thing to mention. I don't want to go through this, but there is a checklist here called the Large Screen App Compatibility App Quality Checklist. It's a good thing to look through. It's a good way to kind of see what are some of the expectations that you would see with a larger device. That means, like, what would be the expectations for something that's running on a tablet versus running on a phone? So that can give you some ideas of ways you might want to change your app and things you might want to do as we're adapting it to these different form factors. But I'll let you read through that yourself. One thing, we're talking about screen densities. In terms of that, there are actually a bunch of different resources in Android called Drawables. Drawable is anything that can be drawn to the screen. Okay, drawable might be an image, it might not be an image. Okay, so images are considered drawables, but they're not the only kinds of drawables. So just a quick overview of what drawables are available. There's a bitmap drawable, which would be anything that's like PNG, JPEG, WebP, as they say. Those are all treated as bitmaps. There's the 9-patch, which I mentioned, which is that scalable side of things. There's also layer lists. Layer lists are a stack of images, so you can stack together a bunch of different drawables and present those as a single image. There's a state list. So state list changes based on the state of that widget. So like you can say, here, use this image when the checkbox is checked, and use this image when it's unchecked, disabled, enabled, pressed, not pressed. So you can change that, provide a set of things. Level list. This level list would be like a battery that's charged. So from not charged all the way to fully charged, or ranges for Wi-Fi signal. Those are places you might see that. Inset drawable, I'm not really familiar with. Shapes are interesting. It's kind of like a vector type of way of doing things. So it's good to take a look at some of those to maybe find out what some of those options are, so you know what those are as far as if you're trying to scale images. But largely we're going to be focused on those, the vectors and the bitmaps. So that's just some things to point out. Localization we've kind of already talked about. So layout variations, remember, that we've done before, right? Remember how we got into the layout variations? You started with one layout. You went up to the top left corner. There's a button you can drop down, and you can say, hey, create a landscape variation or create a tablet variation. Okay. So that was the original way that we showed you how to create variations. Forget those buttons exist. If you go down that route, you're going to find yourself making 4 different variations of the same screen. Don't do that. Okay. So the way that I want to create variations is a little bit different. Okay. So the way we're going to create variations is going to be actually we go just create a new file. And it's going to start with a brand new file. When we create that brand new file, it will give us the option of what are the qualifiers, what are the things that determines when you use that file. Okay? So that's the way we're going to set that up. So layout variations is one of the things I want you to do on LAMP, but the first thing I actually want you to do is something called dimensions, right? Layout variations work. Layout variations are helpful. There are cases where you definitely need them. Oftentimes they are the kind of the heaviest tool in job because they require a lot of duplicate code to make layout variations. So a lot of times what we'll do instead is we'll just use dimension resources. Okay, dimension resources allow us to give a little bit more flex to things that are fixed widths, because it does turn out, like we were talking with that particular layout, you know, okay, well the column with the labels needs to have a fixed width. If I'm putting images into my app, generally they're going to have a fixed width somewhere, okay, whether it be on the width or the height or both. But those things I need to sort of flex. Does that make sense? Oftentimes I may need to set a fixed width, but then have that fixed width change from device to device to device. Okay.